So whoever's watching this video, whoever needs section 2.5 notes, this is inequalities. Inequalities, you solve very, very similar to when you have an equality, which is an equal sign, but inequalities are less than, greater than, less than or equal to, and greater than or equal to, okay? Meaning that you have a range of solutions rather than just one value of x. So if you were solving like x minus 3 equals 5, you would add 3 to both sides, and x would be equal to 8. There's only one answer that works. That's it. Versus if you have x minus 3 is less than 5, you would add 3, so x is less than 8. That means that any number that is less than 8, not including 8, because we don't fill the dot in, so 8 does not work, 7.9 would work, 7.99 would work. Any number less than 8 you can plug into this equation, and it will be less than 5. Good? Make sense? Okay. All right, so inequalities, less than, greater than, less than or equal to, greater than or equal to. Sometimes they will write this as interval notation. Interval notation. Let's say you have x is less than 2, okay? In interval notation, which is over here, they will write that as 2, negative infinity, comma 2. That's an infinity symbol. Negative infinity, comma 2. This is interval notation, okay? Numbers that are less than 2 go all the way down to negative infinity and on up to 2, okay? Now, if you have, like, let's say x is greater than or equal to 3, this time you start with 3 and you're going to positive infinity, but since it can be equal to 3, instead of using a parenthesis, you use a bracket, okay? Now, what do you put on the other side of the infinity? You still put a parenthesis. The only thing that you put on either side of an infinity is a parenthesis, because infinity is not an exact number, okay? If it's an exact number and you are looking at that exact number like 3, it can be equal to 3, you use a bracket. Infinities, you only use infinity, all right? So that's a scenario when you use those two. Now, what happens if you have like negative 2 is less than x is less than or equal to 3? What does that look like? What would that look like? Parenthesis, negative 2, comma 3, and then bracket. There's no infinities because you are in between two numbers. Parenthesis, bracket. Make sense? So if you're only doing one side of it, you have parentheses, and you have infinities, either negative infinity or positive infinity. And make sure you're going in order. So like 3 comma infinity, you wouldn't want to flip those around because infinity is not to the left side of 3. And negative infinity is not on the right side of 2. Does that make sense? You want to write them in order like that they would come in a number line. Trent Court would always switch those around. So if he were to write this, he would write 3 comma negative 2. Negative 2 is on the left side of 3 on a number line. So make sure you write them in that order. Okay, whatever. All right. So solving inequalities these 3 principles work for solving equalities. So you're adding or subtracting the same thing on both sides of the inequality. Like up here, I'm adding 3 on both sides, okay? Or subtracting 3 on both sides. What you do to one side, you have to do to the other side. Multiplying or dividing on the same side. Now, the only deal is when you multiply or divide the inequality by a negative, you are flipping the sign or reversing the direction of the inequality. You flip the sign when you multiply or divide by a negative. Okay? Multiply or divide by a negative, you flip the sign. Does that ring a bell? You remember doing that? Flip the sign? Okay. So let's solve this guy. Down here, now, I have 3 pieces basically going on at the same time here. This one, this one, this one. 3 pieces, okay? If it helps you to do this, 2 is less than or equal to 3x plus 5, and then 3x plus 5 is less than 2x plus 11. Go ahead and do that. Separate those into 2 separate pieces. So I have this piece going on, and I have this piece going on. Those 2 pieces, okay? And then solve them individually. You can actually solve this with 3 pieces going on at the same time. And because I know that you guys like to skip steps, we're going to solve the 3 pieces all at the same time, okay? So let's do that because that's the fastest way. But by all means, if you want to separate them like this, you sure can, okay? When you're doing this, you're trying to get x on the inside. Oh, shoot. Now this isn't going to work because we have a 2x on the other side. We're going to have to split this into 2 pieces. Crap. Sorry. We're going to have to split it into 2 pieces because of this guy right here. Darn. Okay, never mind. This isn't going to work. So let's go ahead and just solve these 2 pieces. So on this top one, what are you going to move? Minus 5. So negative 3 less than or equal to 3x. And then divide by 3, divide by 3. So x is greater than or equal to negative 1. It's blurry. Thank you. There we go. X is greater than or equal to negative 1. If you don't like it written like that, you can write it like this. And flip that around, but make sure you flip the sign. Did I need to flip the sign like when I added or divided or anything up here? No, right? Because I didn't divide by a negative. The only time I flipped the sign was to flip the entire thing completely around. So that's the first one, okay? And then this one right here. Let's subtract the 2x. And can we subtract the 5 at the same time? Okay, so 3x minus 2x, x is less than 6. There we go. Okay, now, this is what you ask yourself. Can I have an x be greater than or equal to negative 1 and less than 6 at the same time? Yes, if that can happen, you're going to write them both together. So you'll write negative 1. I'm going to flip that symbol around again. Less than or equal to x is less than 6, and it looks like that. If you want to write that in interval notation, negative 1 with a bracket, comma 6 with a parenthesis. Does that make sense? If it makes sense to have this happen and this happen at the same time, you go ahead and write them as one piece together. Okay, so now x is the only numbers that are living between negative 1 and 6. Okay? Now we go over to the other one, and I'm guessing these aren't going to be able to be written together. Okay, this is an and statement, basically. They call these and or. That is an and statement because x can be greater than negative 1 and less than 6 at the same time. Over here, if you separate these, this is one piece. So 4 less than 3 minus 5x. And then the other one is this piece, 3 minus 5x is less than 18. Okay, and then we solve this guy. Oh boy. Let's do the top one first. So what do you do there? Minus 3. So 1 less than negative 5x. And then, yuck, divide by negative 5. So negative 1/5, I'm running out of room, less than, oh no, shoot, greater than. Yeah, did you flip it? Because we divided by a negative. Negative 1/5 is greater than x. Or, I'm going to write it over here, x is less than negative 1/5. I just make sure the arrow is always pointing the same direction of x. So if it's pointing toward x here, I want it pointing toward x when I flip it around. Okay, so that's one of the pieces. Now this one, subtract 3. Negative 5x is less than 15. Divide by negative 5. X is greater than negative 3. X is greater than negative 3. Okay, now, can you have an x, the same number for x, that is both less than negative 1/5 and greater than negative 3? Think about where this lives. Negative 1/5 is here. Oh, shoot, negative 3 is over here. Negative 1/5 is there, negative 3 is over there. So if x is less than negative 1/5 and x is greater than negative 3, that can actually happen. So that's another and statement. They tried to trick us. Okay, so we can write that together. We would say negative 3 is less than x is less than negative 1/5. So that's another and. They tried to trick us. If you write that in interval notation, negative 3, comma, negative 1/5. Parentheses around both. That will work either. Also, either, also. Whatever. Okay? All right. How do I want to do this? Okay. Okay, so we're going to solve this next one with a calculator, as it says, obviously. And you can do this with your graphing calculator, or you can do this with Desmos. I'm going to do it with Desmos. So if you guys want to open up Desmos or just watch me watch what I'm doing, that's fine. Class resources, Desmos. Okay, now since we have two equations, actually let's just do this. This will make it easier. Let's move this stuff onto one side. Let's move all this junk from here over to here. So that will make x to the fourth plus 10x cubed plus 21x squared. The 40x will become negative 40x. Minus 80 is greater than 0. Is greater than 0. Move everything to one side of the equal sign, or the inequality sign. Okay, this will make this a lot easier for you to see. Okay, so I'm going to graph that entire thing. X to the fourth plus 10x to the third plus 21x squared. Oh my gosh. 40x minus 80. And that's it. Enter. Okay, he's doing some wiggly things up there, but I really only care about this thing. Okay. All right, I graphed that whole thing, just the left side, and I want to know where that is greater than 0. Basically, this is like saying, where is it above the x-axis? That's what greater than 0 means, right? Bigger than 0 means that your y's are above the x-axis. So if I'm looking, I'm trying to see these points at where it's above the x-axis, okay? This is like veering off to the left side. This is veering off to the right side, okay? If I click those points and I'm trying to locate that, anytime x is less than, which is on the left side, of negative 1.53, my answer is greater than 0. Does that make sense? Anytime it's over here on the left side of negative 1.53, my x's are over here on the left side of negative 1.53, my answer is above the x-axis. So one thing that I will write here is one of my answers is x has to be greater than negative 1.53. Does that make sense? And then over on this side, no, shoot, sorry, that should be less than, not greater than, less than, because I want to know lower. These x's that are up here are actually x's that are less than negative 1.53. Even though it's above the x-axis, this x value right here is negative 1.55. So x's that are less than negative 1.53 are x's that I want. Now these ones over here, since it's veering off to the right side, I want x's that are greater than 1.892. X has to be greater than 1.892. You can see how that works? Okay, veering off to these sides. These x's over here are greater than 1.892. These x's are less than negative 1.53. Yeah, and that's where my y values are positive, or why my y values are greater than 0. Okay? Now, is it less than or equal to negative 1.53 and greater than or equal to 1.89? Why not? If you look at the original equation, it's not equal to in the original equation. So it's not going to be equal to on mine, because it can't be equal to 0. It's only greater than 0, right? Does that make sense? So these are my only two solutions. That's finding the answer by graphing. Now, you can easily do that with any of these other ones to check, to make sure. Okay? And there's that. Does that make sense to you? Visually, it's kind of hard to see maybe, but that's it. Okay? Okay. All right, since I've like yucked my entire paper up here, I'm going to get on a new sheet of paper. So we're going to do this one. 2x squared plus 3x minus 4 is less than or equal to 0. This is a quadratic inequality. Can I do this by factoring? 2 and negative 4 is negative 8. Can I multiply to get negative 8, but when I add them, give me 3? Like to use the factor by grouping method? I don't know if I can. I don't think I can. I don't think I can. So how do we solve that quadratic thing? We can't factor it. How do we solve it? The formula. The quadratic formula. Negative b plus and minus square root b squared minus 4ac all over 2a. Okay, we got lots of time now. Okay, negative b. Negative 3 plus and minus square root b squared is 9 minus 4 times 2 times negative 4 over 2 times 2. I'll give you a chance to catch up. Maybe. And I'm going to need somebody with a calculator. A couple people with a calculator, maybe. Okay. Negative 3 plus and minus. Negative 4 times 2 times negative 4 is something like 32. Is that right? Positive 32. But then you have to add that to 9, so you have like the square root of, I don't know, 41 over 4. Okay? Now, let's go ahead and separate that, and we'll put those as decimals to make this a little bit easier. We want negative 3 plus the square root of 41 over 4, and we want negative 3 minus the square root of 41 over 4. What are those two decimal things? If you're doing this on a non-fancy calculator, make sure you're using parentheses. Negative 3 plus the square root of 41 divided by 4. 0.85. Did somebody do that already? Yeah? Yeah, that's what you got? Okay, and I'm just going to go up to my calculator. I can go up, change that to a minus, enter. Negative 2.35. Okay. Okay, now we have our two answers. I call these two guys here critical numbers. Jamie and Colby, you're going to know what I'm talking about with critical numbers, because that's what we call them in calculus. At least I hope you know what I'm talking about. I have no idea, like, where my symbol, what my symbol looks like now is like x greater than 0.85, is x less than negative 2.35, whatever. So I have completely lost what direction my sign should be flipped. So here's what I do. If all else fails, I put these on a number line, negative 2.35 and 0.85. I put my critical numbers on a number line, okay? And then I pick a point here, and a point here to test to see where my x should live in relationship to that number line. So what's a number that's less than negative 2.35? Number that's less than negative 2.35. Negative 3. Sure. Okay, so what's a number between negative 2.3 and 0.85? What? Pick the nice number. What's the nice number? 0 is the nice. Always pick 0 whenever you can. Always pick 0 whenever you can. Now, what's a number greater than 0.85? 1. Okay. So we're going to plug those numbers into our original equation, which is this guy. 2 times negative 3 squared plus 3 times negative 3 minus 4. We want to see if that's less than or equal to 0. Somebody do that for me. I'm going to write out the next one. 2 times 0 squared plus 3 times 0 minus 4 is less than or equal to 0. I'm just plugging these into the original equation, which is over here. 2 times 1 squared plus 3 times 1 minus 4 is less than or equal to 0. Okay, this is 2 times 9, which is, do a different color, 18 minus 9 minus 4. That is like 5. 5 is not less than or equal to 0, so that does not work. I'm going to put a big fat X on that side of my number line. 0, 0, 0. Those cross out because anything times 0 goes away. So we have negative 4 is less than or equal to 0. Is that true? Yes, so I'm going to circle this region of my number line. And I have 2 times 1 squared, which is 2, plus 3 minus 4. That's 5 minus 4 is 1. 1 is less than or equal to 0? No. So I better put a big fat X on my number line.
Wait, so if you just plug in 0 and it doesn't work, then the other two have to be right?
Most of the time, yes.
Okay, why would they not
Most of the time, yes.
Why would they not be? Why would they do this? Why?
I don't know.
Why?
Every once in a while, it will happen that, like, yeah, that 2 of them work. Most of the time, you can cheat and just test this one in the center, and if it doesn't work, the 2 outsides work. If it does work, the 2 outsides don't work. Does that make sense? Okay. So what I have going on right now is negative 2.35 is less than x, which is less than 0.85. Now, is it less than or equal to, or just less than? Look at your original equation. This one right here. Equal to. There's an equal to symbol. So this is going to be my solution. Or if you write in an interval notation, it's going to be brackets around both sides. Okay? That seemed like a super, super long process. But after you do it so many times, you can skip steps like Josh just said. You know, just test the middle. Okay, great. You can skip some steps. What? Yes, you can. Yep, you can. You should be able to just test the middle. In calculus, this is when it won't work. In calculus, we start to solve things that are bigger than quadratics, so you'll have more than 2 critical numbers. So you'll have like 3 on a number line. And then I'll have 4 regions to test. And then it's like, okay, which regions do I test? Which regions do I not test? That's when it doesn't work. That's when it poops out. So when you only have 2 critical numbers, it's either going to be the inside or going to be the outsides. But when you have 4 critical numbers, like when we start to doing like calculus and stuff, that's when you'll have to test more than 1 region. Does that make sense? Okay, great. Okay, so there's that. Now this one, solve an inequality. This one is actually easier than the last one. I still put it on a number line though. Since they have it factored down for us, we go ahead and set each one of these equal to 0. X plus 5 equals 0. X minus 2 equals 0. And x minus 8 equals 0. And this gives us our critical numbers. Now, even though this is to the 6th power, if I take x minus 2 equals 0 and x minus 2 equals 0 and x minus 2 equals 0 6 times, I'm still going to get 2 as an answer, right? So we only have to do it once. Does that make sense? So 6th power means nothing. No, it doesn't matter. No, because you're still going to get 2 as an answer 5 times then. So we just set those equal to 0. The 6th power doesn't really do anything for us, all right? So this is x equals negative 5, this is x equals 2, and this is x equals 8. Okay, I still put those on a number line just in case I maybe got my stuff screwed around a little bit. Okay, so number line here, my numbers were negative 5, 2, and 8. Negative 5, 2, and 8. Ah, here you go. Here's a scenario, Josh, where you have 3 critical numbers and 4 ranges. So not just in calculus, in this class also. What's a number that's less than 5 that we can test? Negative 6, sure. All right, I'm going to show you how to make this really nice, so don't start plugging these in yet. What's the number between negative 5 and 2? Use the easy one, 0, always. Okay, 2 and 8? 5, and bigger than 8? 10, sure. Okay, so we're plugging these into, oh boy, my original equation, which was something. Let me go down. The original equation is this. X plus 5, and x minus 2 to the 6th power, and x plus 8, and is less than or equal to 0. Okay, this is how you cheat. This is how you make this really, really easy. Okay? Our first number that we're testing is negative 6. Okay? I do not care what this number comes out to be. All I care about is the fact if it's less than or greater than 0 or not. So don't worry about actually trying to find the number. Just worry about the fact that it's positive or negative. So if I plug negative 6 into the first one, negative 6 plus 5 is going to give me a negative number, right? Negative 6 minus 2 is another negative number, but if you take it to the 6th power, it's going to be a positive number, right? We don't care what that number is. I just care about it whether it's positive or negative. And negative 6 plus 8 is a positive number. Okay, so if I take a negative number times a positive number times a negative number, that will give me a negative number. And is a negative number less than 0? Yes, I don't care what that negative number is. I just know that it works because we're just comparing it to 0. Does that make sense? I'm totally cheating, but it's legit. Okay, the next one, we're going to take 0 and plug it in. 0 plus 5 is going to give me a positive number. 0 minus 2 is negative, but when you take it to the 6th power, it's positive. In fact, anything taken to the 6th power is going to be positive. So this next one's going to be positive. This one's going to be positive also. Okay, for my next two scenarios. That's always going to be positive. 0 plus 8 is another positive. So positive, positive, positive makes positive when you multiply them. And is that less than or equal to 0? No. Make sense? Yeah? Okay. Next. 5. 5 plus 5 is a positive number. We don't care what it is. Anything to the 6th power is positive. 5 plus 8 is positive. So we have another positive, 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 which does not work. There's another region that we can cross out. Yeah? Are you guys checking to make sure I'm doing these right? Because I can make a mistake. Okay. Now the last one is 10. 10 plus 5 is positive. This middle one's positive again. X plus 8 is positive. Positive, positive, positive. Wrong. So the only answer that we should have is x is less than negative 5. Now if we look at our original equation, we have an equal to symbol. So that's our answer. If you write that in interval notation, it goes negative infinity to negative 5, bracket, parentheses. That's interval notation. That's what that would look like. Good? Does that make sense? That would have been doing the positives and negatives when you're comparing to 0 is a lot faster than actually computing the value. Does that make sense? Okay, so just worry about the positives and negatives if you have 0 on the other side. How many problems do we have left? A lot? One? Woohoo! Okay. All right. Oh man, a computer store has determined the cost C of ordering and storing laser printers. If the delivery truck can be at most 450 printers per order, how many printers should be ordered at a time to keep the cost to below $1,600? Okay, if the delivery truck can be at most 450 printers per order. Okay. How many printers should be ordered to keep the cost below $1,600? Okay. We're going to just keep 450 in the back of your mind really fast. Because we're going to deal with him, but not right now. Okay? We're going to deal with the 1,600 first, and I'm going to input that for my cost. But instead of this being equal to, we're going to have a different symbol here. 2x plus 300,000 over x, like this. That's what we've got going on there. Okay. And we're going to have a different number or a different value in there. It's not going to be equal to. We want our cost to be below 1,600. So this thing right here on the right side has to be in what relationship to 1,600? Less than. Can it be equal to? It says below 1,600. If it said less than or equal to 1,600, we would put the equal sign. But below 1,600. 1,600 is not below 1,600. So we don't put equal to. Okay? So we've got this going on. Now we need to figure out how to solve that. Yuck, yuck. Since there's an x in that denominator there, I'm trying to see what would be the easiest for you to think about. Let's kick this 2x to the other side. So we've got 1,600. It's going to be easier for you to see it this way. Plus 300, no, wrong. Just 300,000 over x. Okay? I want to get this x out of the bottom here. How do I bump that x to the other side? Multiply by x times x, and I'm going to times this whole thing by x again. Okay? So over here, I'm going to put these in order. I'm going to write negative 2x squared plus 1,600x is greater than 300,000. Like that. Okay? Does that make sense? Yes? Okay, now let's put these two back onto the other side so that my x squared is positive. So 0 greater than 2x squared plus 1600x plus 300,000. Oh, I'm sorry, minus. Yes, you're right. Thank you. Okay, then what? That's a quadratic. We're going to end up solving that quadratic, so we either have to factor down or use the quadratic formula or something of that nature, but there's one thing that I can do first. Divide everything by 2. Everything divides 2. 2, 2, 2, 2. So 0 still. X squared minus 800. X plus 150,000. Okay, is there something that I can multiply to get 150,000, but when I add them, give me negative 800? We'll have like a positive and a negative going on. I'm thinking like a combination of 3 and 5, but that's maybe not going to work. Can you think of anything? Should we use the book to cheat? Why not? Nope. They went ahead and used decimals. They used like graphing stuff because it comes out as a decimal. So we could use the quadratic if you want to, but let's hop back over so you have another example of what like Desmos looks like. Okay, so now I'm going to cross this off. I'm going to do y is equal to x squared minus 800x plus 1500, and I'm not going to be able to see my graph, or 150,000. Not going to be able to see my graph because it's going to be like all the way over. All the way over here. All the way over here. Okay. Okay. 400. If the delivery truck can bring at most 450 printers per order. Confusion. Did I type that in right? Minus 800. 150,000. Oh, okay. I see. Okay, now, if you look at this graph here, this point right here at 300 is where it crosses the x-axis, right? Because we're comparing to 0, where we're seeing where it crosses the x-axis. Before, we were trying to figure out where it was above the x-axis. But here, we're doing below because we want to know when this is less than 0. So we're trying to figure out whether that is less than 0. So if I want to know where the y-coordinates are less than 0, like down here on my graph, my x-coordinates have to be bigger than 300. All of these points that are less than 0 on the y-axis have x-coordinates that are bigger than 300. Do you see that? Okay. So I want my x's to be greater than 300. Okay. Now you also see here that it has to be less than 500. Does that make sense? X has to be less than 500. But in the back of your mind, you were supposed to put the fact that we had 450 printers were the only thing that we could do, right? We only had 450 printers. So instead of being less than 500, that number is now restricted down to only 450. Does that make sense? Because the story problem restricted that down further for us. So basically the number of printers that I could have looks like this. Has to be greater than 300 but less than 450. Can it be equal to 300 and equal to 450? No, because my original equation was just greater than and not equal to. That's what you look at. You look at your original equation. So I have this going on. If you write that in interval notation, I have to have somewhere between 300 and 450 printers with parentheses around them. That's how many I can have, and that's it. Good? Make sense? Clear as mud? Okay, great. All right, let's see if this recorded. I really hope it did.